press the bell icon on the YouTube app and never miss another update.
Welcome children. So we have discussed it so far coordination chemistry and we are discussing the paper here now. So this is part 2 of paper discussion, that is coordination compounds, part 20. Let us see question number 56. Which one is the most likely structure of CrCl3 6 times water if 1/3 of total chlorine of the compound is precipitated by adding AgNO3 to its aqueous solution? So if you see the compound is, this is question number 56, CrCl3 6 times water. Okay, what you are doing to this compound is you are adding AgNO3, silver nitrate, and according to the question 1/3 of total chlorine of the compound is precipitated. So when you treat this with AgNO3, 1/3 of, there are how many chlorine atoms present? There are 3. So 1/3 of chlorine means you will get 1 mole of chlorine out. 1 mole of chlorine with silver will combine and result in the formation of AgCl, because 1/3 of total chlorine has been precipitated out. So what is the formula of that particular compound? Very simple. Since you are getting 1 mole of chlorine, so the number of chlorine is acting as counter ion is only 1. So the formula will be CrH2O 4 times Cl2. Outside you will get Cl, and there will be 2 moles of water acting as water of crystallization outside. Because on treatment of this will give you a complex ion. Charge of the complex will be +1. This is -1. Here it is -1. Chromium will be under +3 oxidation state on the whole. Yes. So you will be able to get 1 chlorine because this chlorine will be free. When you treat this with silver nitrate, AgNO3, you will get 1 mole of AgCl respectively. So the correct answer for this question will be which one? CrCl, H2O 4 times Cl2 and outside Cl, twice water molecule. That's it. This will be the formula of the complex. So that's option, which one? Option 3 will be the correct option for this. Next question. Question number 59. Question number 59 is asking us what, children? Have a look on question number 59 now. So question number 59, let's have a look on question 59. Which one of the following is expected to exhibit optical isomerism? So which is expected to exhibit optical isomerism? We have learnt out it clearly. Trans will be optically active or inactive? Inactive. Cis will be optically active. Correct option is option 4. This is direct question only. We have done it many a times so far. So question 59, option 4. Cis PTNH3 twice Cl2 will not show because it is square planar molecule, right? With DsP2 hybridization, it is square planar, and square planar complexes do not show optical isomerism. Trans will not exhibit optical isomerism, neither. So no, option 4 will be the correct option. Next question. Question 60. What's it asking? An aqueous solution of potash alum. What is the formula for potash alum, children? It is K2SO4 Al twice, SO4 thrice, and X times water molecules are attached to it. You know that what are double salts? The substances which on dissociation will give you all types of ions because they dissociate completely. So we will get the potassium free here, we will get SO4, and we will get aluminum as well. So in 3+ state, SO4 will be 2- state, potassium in plus state. So 3 different types of ions will be obtained on dissociation of potash alum. Correct option will be option 4. So 3 types of ions. This is the formula of potash alum. Right, next question. Question 61. The complex used as an anti-cancer agent is, remember that cisplatin is used as an anti-cancer agent. So that's option 2, cis PT Cl2 NH3, because this can A2B2 type molecule. This can exist in cis and transformers, but it is cis form is used as an anti-cancer agent. Option 3 correct option. Next one. 64. What's the question asking? 64 question. The formula of the complex tris ethylene diamine cobalt 3 sulfate is? You can have a look on the question directly. Tris ethylene diamine, because it's a polysyllabic ligand and also it's a complex ligand. Thus, we have to use tris for it. So you have, and the number of donating atoms are more than one. So we are using bis, tetrakis, so on and so forth. Tris ethylene diamine. So you can see that all the options, if you see, tris ethylene diamine, cobalt 3. Now you can see that cobalt is here, right? Ethylene diamine molecule is there 3 times. According to the question, what's the name of the complex? Cobalt 3 sulfate. So outside you have SO4. Now understand it well. Cobalt under +3 oxidation state, SO4 will gain 2 minus, right or not? So if I suppose cobalt is 2 times, SO4 2 minus, the number of electrons lost by cobalt are how many? 3. So +3 oxidation state. So it is 2 electrons gained. It should be how many times? 3 times. SO4 thrice. So if you look on the option 4th, what's the name? Option 1st, what's the name? Bis ethylene diamine. Option 2, tris ethylene diamine, but sulfate is inside the coordination sphere. And you can see the name sulfate has been written at the end after giving oxidation state. That means sulfate is acting as a primary valency. That sulfate is a counter ion. So either option 3 or option 4 will be the correct options for you, right? But in order to balance the molecule, cobalt under +3 oxidation state, right? If you see option 3, COEN thrice, SO4 outside. That will, cobalt is under +3 oxidation state, only under +2 there. Because SO4 is outside, only 2 electrons are needed to be lost. So there cobalt will be under +2 oxidation state. So correct option will be option 4. Next question. Question 65. The magnetic moment of MnCN6 3- corresponds to how many unpaired electrons? Now the question that's asking you is question number 65. Complex is MnCN, how many times? 6 times. Charge is 3-. Have a look on this question carefully. Manganese is under +3 oxidation state. Atomic number of manganese 25. Electronic configuration of manganese is 3d5 4s2. It has lost how many electrons? 3 electrons, 2 from S and 1 from D. Manganese 3d5 4s2. Lost how many electrons, children? 3 electrons. Once it has lost 3 electrons, 2 from S, 1 from D, it's an octahedral field. It will be T2G, EG set. So this is our T2G and this is EG. Now you can see the number of electrons remaining are 4. So 1, 2, 3. It's a strong ligand, pairing will occur or not, right? So the number of unpaired electrons will be how many? 2. So paramagnetism here is due to how many unpaired electrons? 2 unpaired electrons. Clear, correct or not? Because pairing will come into play in this molecule. Right, next question. Question number 66. What's the question asking? The correct IUPAC name of the compound, very simple it is. What's the name? Tris ethane 1,2 diamine. Tris ethane 1,2 diamine. You can see outside sulfate. What's the oxidation state of sulfate? SO4 2-. Total number of electrons to be lost by cobalt should be 3 because there is complexes twice. So cobalt will lose 3 electrons. One more cobalt will lose 3 electrons. So oxidation state of cobalt will be 3. Correct option will be tris ethane 1,2 diamine cobalt 3 sulfate. Correct option will be option 3rd. Next question, children. Question number 71. The delta zero of coordination complex of metal ion right, question 71. Delta zero of coordination complex of metal ion 3D is 1000 kilojoules per mole. Good. If the energy of T2G orbitals is how much? Minus 400 kilojoules per mole. The energy of EG orbitals is question number 71. We know the crystal field splitting in octahedral field equals to what? T2G and EG set. According to the question, we have been given this is T2G set and this is EG set. Crystal field stabilization energy for the two is given to be 1000 kilojoules per mole. Okay, it's given 1000 kilojoules per mole. If the energy of T2G orbitals is how much? 400. So energy of T2G orbitals is how much given? 400. So what can we write down? Delta 0 equals to, it's an energy difference between the two, right? Like in Bohr's model, you use E2 minus E1, it will be E minus T2G, because this is E2, this is E1. So delta 0 equals to E2 minus E1, that is EG minus T2G. Now what is delta 0? 1000 equals to, what is EG energy given to you? Given or not given? EG is not given, T2G is given. T2G is given how much? Minus 400. Oh, yes. So EG minus of minus 400, which is given, plus it becomes here on the other side minus 1000, minus minus will be plus. It comes here, it becomes minus 400 will be the energy of EG. So that will be 600 kilojoules per mole. Correct option will be option 2 for this, 600 kilojoules per mole. Followed? Good. Question 73. An example of sigma bonded organometallic compound is Grignard's reagent, ferrocene, Z salt, rethocene. They are all pi bonded organometallic complex, already discussed in the previous discussions. Right. Question number 75. The pi bonded organometallic compound which has ethene as one of its component is, it is Z salt. And what's the formula for that? We know it, KPtCl3 C2H4. This is what bonded? Pi bonded organometallic compound. Not only is it pi bond organometallic compound, but we are also using this by word neta2, because that means the total number of carbons linked with the central metal atom by what bond? Pi bond. Correct option will be which one? This salt. Next question, children. Question number 79. What's it asking? The CFSE of CONH3 6Cl3 is. Question number 79. We have to find CFSE of CONH3 6 times CONH3 6 times complex closes Cl3. Let us do the basic rule. T2G set, EG set. We know it very well. So we got T2G and EG set, children, right? Now what is crystal field stabilization energy equal to? What? Minus 0.4 of delta 0 into number of electrons in T2G plus 0.6 of delta 0 into number of electrons in EG plus pairing is in octahedral field. That's a basic formula that all of us know. Now looking on cobalt NH36, cobalt will be under plus 3 oxidation state. Cobalt is 3d7 4s2. Cobalt 3 plus will be 3d6. Am I right? Now ammonia is a strong field ligand. There are 6 electrons on the hole. So we'll have 1, 2, 3. Pairing will occur or not, right? 4, 5, 6. Means all the electrons will go to which set? T2G or EG set. They will all go to T2G set. And we know CFSE is calculated by minus 0.4 of delta 0 into number of electrons in T2G. How many electrons are there in T2G set? This is T2G set and this is EG set. What's the number of electrons in T2G set? First, there are 6 electrons and stability occurs by the value of minus 0.4. So 6 into minus 0.4 will be minus 2.4 of delta 0. How many pairings are there? 3 pairings plus 3 pairings in octahedral field. This needs not to be taken in count because this is not existing there. There is no electron in EG set. So the correct option will be minus 2.4 of delta 0. Plus how many pairings? 3 pairings. So they have not mentioned 3 pairings here. Correct option will be option 3 for this question. Next, question number 80. What's 80th question asking us, children? It's asking us, which of the following will not give precipitate to AgNO3? So we have question 83 here. Which of the following will not give a precipitate with AgNO3? Very simple. Have a look on all the complexes. Which one will not give you test for AgNO3? The one which does not have chlorine acting as a primary valency with it, right? Because in all the complexes you see option 1, there is no chlorine out of the coordination sphere. So it doesn't break off, no precipitation with AgNO3. Second one will definitely give you with chlorine. third one will also give, fourth one will also give. Second will give you 1 mole of AgNO3, AgCl. Third will give you 2 moles. Fourth will give you 3 moles. First option will not give you any mole because all the chlorines are in the coordination sphere respectively. Question number 80. Question number 88. Or you can move to question number, I'll take simple questions into play. 89. Go to 89th question. 89th. The sum of coordination number and oxidation number. Sum of coordination number and oxidation number of the metal in the complex. So M, we have the complex, question number 89. So we have the complex M, En twice, then C2O4, then outside we have chlorine. Very good. What is the sum of coordination number and oxidation number? Let us first of all find out oxidation number. This is oxalato group C2O4, and we know for this oxidation state is 2 minus because we know C double bond O, O minus, and C double bond O, O minus. This is oxalato group. Ethylene diamine is a neutral ligand. So the number of electrons needed by C2O4 are 2 minus. This needs 1 more. Total number of electrons needed are 3. So metal atom should be under +3 oxidation state. Now, so this is what ligand? This is a bidentate ligand. Even En we know it's also bidentate ligand. En is also bidentate ligand. Now, this is bidentate ligand and each can donate from how many places? 2 places. So from En, each En, coordination number will be 2. There are 2 En, so coordination number from En will be 4 on the whole. And there is, this one is also bidentate ligand, coordination number will be again 2, that is 6. So coordination number in the complex is what? 6. And oxidation number is how much? 3. So that sum of coordination number plus oxidation number will be equal to 9. Correct option will be option 3. Right, next question. Question number 94. Let's see question 94, children. What's it asking? Yes. An aqueous solution of titanium chloride when subjected to magnetic measurements gives 0 magnetic moment. Good. Assuming the octahedral complex in aqueous solution, the formula of the complex is, it should be simple. Because this is titanium chloride complex here, so T titanium, we know atomic number of titanium is 22, so it will be 3d2 4s2. This is the valence electronic configurations here, 3d2 4s2. It gives you magnetic moment how much? 0. Magnetic moment is how much? 0. If it is magnetic moment is 0, that means there is no unpaired electron present at all. Yes. Now, if you look on the first option, TiH2O6Cl2, TiH2O6 coordination system closes, Cl2. Here the number of electrons lost by titanium should be 2, which are gained by chlorine. Both of these s electrons will be lost. D will have 2 electrons and both the electrons in the 5 orbitals will remain unpaired. So first is not the correct option. Second one is TiH2O 6 times TiH2O6 and outside there is Cl4. Titanium will have to lose 4 electrons here to counteract these chlorines. So when it is losing the 4 electrons, for chlorines to be gained, this complex will be +4. So 2 electrons from S and 2 from D will be lost. So there will be no electron in D at all. Thus, magnetic moment will be 0 because there is no unpaired electron. In the third case, if you look, TiCl3, there will be 1 unpaired electron because only 3 electrons will be lost. So 3d1 configuration. TiCl2, 3d2 electronic configuration. So the correct option, children, for us in this case will be when all the 4 electrons are lost, there will be no unpaired electrons. So option 2 will be perfect option for us for this question, 94th. Good. Question number 95. Which of the following is not a complex compound? Simple. Complex compound will not give you test for everything. Question is which of the following is not a complex compound? Correct option is option 3 because this is potash alum. A while earlier we solved one question. Which of the following how many ions will be given by potash alum? Just a while earlier we solved one question. So correct option will be option 3 children because it will give test for potassium also, sulfate also, aluminum also. Because double salt loses its identity. It maintains the identity in the solid state but loses its identity in aqueous state. But complex compounds do not. So the correct option will be option 3. Next question. Let's move directly to question number 102. Because all these questions in between what have been asked, they are direct questions, children. So let us see question number 102 now. Hybridization of central atom, shape and magnetic moment of COH2O6 3+. COH2O6 3+ is. So the complex is, I'll write it here. Question number 102. COH2O6. What's the charge mentioned according to question? 3+. Now cobalt will be 3d7 4s2. Lost how many electrons? 3 electrons. So 2 from S and 1 from D will be lost. So it will be 3d6 now for cobalt. Now when it breaks in an octahedral field, it will give you two sets, T2G and EG. So this is our T2G set and this is our EG set. The number of electrons in D are 6 and water we know is a weak ligand. So it will not force pairing. 1, 2, 3, 4, 5. 6 electron obviously will enter into T2G. Hybridization of central metal atom. So naturally this EG set and T2G set all are used. So obviously because 6 ligands are coming. So hybridization will be sp3d2 because inner D is not used, outer D will be used. So sp3d2 will be the hybridization. Correct option will be directly option 2. Naturally because there are 6 ligands coming, it will be octahedral shape and magnetic moment will be with respect to how many ampere electrons? 4. It will be with respect to 4 ampere electrons like we solved a while earlier the question. Which one? What was the question? It was Kn Mn F6. What will be the value of the N and what's the oxygen state of manganese? There also magnetic moment was 4.9 Bohr magnetons. That means number of unpaired electrons will be 4. So for manganese to have 4 unpaired electrons, it is 3d5 4s2. Right? So it has lost 2 electrons from where? S. Oh yes or no? To have 4 unpaired electrons, oxygen state of manganese should be, it is -1. So if it is under +2, there will be 4 potassiums. So +2 oxygen means 2 lost from where? 2 lost from where? M1. I said a while earlier. Now same here 3d6. So there will be 1, 2, 3, 4, 5, 6. So paired electron is there as well. Number of unpaired electrons are 4. Magnetic moment root of n into n plus 2. Oh yes or no? So n 4. So 4 into 4 plus 2 root value, that's root of 24. That's 4.9 Bohr magnetons only. Clear? Clear? You got this question as well? Clear? Yes. Next question. So here what will be the oxygen state of manganese here? You can calculate it out. Right? Next question, children. Question number 103. In NiNH3,4SO4, the effective atomic number of nickel is very simple. Already we know how to solve these questions directly and clearly. What's it? NiNH3 4 times outside SO4. Very simple to have a look on this question, children. We have to calculate effective atomic number. Right. Nickel SO4 is 2 minus. That means nickel has lost how many electrons? 2. What is effective atomic number equal to? Atomic number minus oxidation state plus 2 into coordination number. What is Z for nickel? 28. Oxidation state is 2 plus 2 into what is coordination number? 4. 28 minus 2 is 26 plus 8. That will make it 34. Correct option will be 34. That's option 1. Next question. Question number 1. 111. Question number 111. We will have a look on. Right, what's the question? Correct increasing order of the wavelengths of absorption in the visible region of the complexes CO plus 3 is. Question is telling is cobalt 3 plus, they have already given you cobalt 3 plus, okay? So it is cobalt 3 plus is already given to you. Now this cobalt is under the influence of En, it is under the influence of ammonia, and it is under the influence of what more ligand? Water. First of all, when we decide the strength of the ligands, what do we find out is that En crystal field splitting will be higher compared to NH3 compared to water. Maximum crystal field splitting will be for En followed by NH3 followed by water, because we know En more than NH3 more than water. This is decreasing order of ligand field strength. En is strongest ligand, water is weak ligand. Now in order to excite electron from T2G to Eg, because splitting in water is least, energy required in water will be less, that means wavelength will be more. But crystal field splitting in ethylene diamine is more. So in order to excite electron from ground state to excited state, excitation needs more energy. More energy means less wavelength. Thus, the order of the wavelengths will be wavelength absorbed in En will be less than wavelength absorbed in ammonia will be less than wavelength absorbed in water. So you can look on the option, children, you can see that complex of En will have less wavelength compared to NH3 compared to that of water. That means it's very difficult to excite electrons in En because CFSE will be more. Excellent. Question number 116. 116. Question is, in an octahedral crystal field, the T2G orbitals, these orbitals, T2G orbitals, which field? Octahedral field. Naturally, in octahedral field, what happens to T2G set? It gets stabilized by the value of minus 0.4, means it is lowered by the value of minus 0.4, lowered means minus, lowered by the value of 0.4, and EG set is enhanced in the energy by the value of 0.6. Have a look on option. Lowered in energy by 0.4 of delta 0. Delta 0 means crystal field splitting energy. Very good. Next question, children. Question number 124. 124. Question 124. What's it asking? 124. Primary and secondary valencies of platinum in PT En twice Cl2 Cl2 is, what's the number of primary and secondary valency? You can see that primary valencies are how many? Primary valency means ionizable valency here. So how many are there out of coordination? 2. So primary valencies are 2 and secondary valencies are how many? What does secondary valency mean? Number of coordinate bonds made with the central metal atom. You can see that very easily from the question. So En, it's a bidentate ligand, so that means from each En 2 Ens will be 4, and from 2 more chlorines 2 more coordinate bonds, total 6. So correct option will be 4, 2 and 6. Next question, children. Question number 134. 134. Right. Low spin complex of D6 cation in an octahedral field will have the following energy. Good question, but a direct question. Question number 134. 134. Good question actually, but it's same question but indirect way. Low spin complex of D6 cation. Low spin complex of D6 cation means low spin D6. Low spin unpaired electrons will be very less. Low spin complexes are usually accompanied in a strong field system. So D6 configuration will mean 1, 2, 3, right? Then we'll have 4, 5, 6. Means all the electrons will pair up. We know that T2G set is stabilized by the value of minus 0.4. When you look on the energy considerations of 10 or 1, what do we call this 0.4 as? 2 by 5. So it is minus 2 by 5. In this, the fractional value has been given to you. So the number of electrons are how many? 6. So it will be crystal field splitting energy will be given by what? 6 into what? Minus 2 by 5. 6 because 6 electrons plus number of electrons in EG. There are no electrons plus number of electrons in EG set plus pairing is in which field? Octahedral field. So that makes it minus 12 by 5 or 2 minus 2 by 5 is technically minus 0.4 because formula is CFSE is crystal field stabilization energy equals to minus 0.4 into number of minus 0.4 of delta 0 into number of electrons in T2G plus 0.6 into number of electrons in EG plus dash pairings in octahedral field. You can write this one also as minus 2 by 5 into number of electrons in T2G plus it is 6, so it will be 3 by 5 into number of electrons in EG plus dash pairings in octahedral field. So what is the number of electrons in T2G set? 6. So 6 2 it will be minus 12 by 5 of delta 0 plus how many pairings have occurred? So 3 pairings in which field? Octahedral field. So correct option will be minus 12 by 5 of delta 0 plus 3 pairings respectively. So correct option will be option 4. Next question. Question number 135. Carnallite in solution in H2O shows the properties of, very simple, it is K plus Mg2 plus and Cl. That's a formula, KCl plus MgCl2 plus 6 times water. Correct option will be option 1 only. That's a direct question only. Next one. Question number 137. Sorry, question number 137. Which cannot exhibit geometrical isomerism? Square planar Ma2B2 definitely. Ma2B2 100% geometrical isomerism. How? MAABB. This is what? Cis. Its trans will be MAABB. This is trans. So it will exhibit. Second one, MA3B3. Definitely it exhibits which one? Facial and meridional. MA4B2. Yes, with respect to B2, cis and trans. MA3B not possible because you will always have 2 cis and 2 trans. This is MA3B. Anyway you do, this is cis, this is trans. An isomer cannot be cis and trans at the same time. It will be cis in one geometrical consideration and trans in other geometrical considerations respectively. Very good. Next question. Question number 143. Question number 143. Have a look. All questions are easy, children, you need to go through it. Which of the following forms chelate complex? Everyone tell me, for making chelates, for making the chelating rings around, for making the rings around a particular central matter, what's the basic condition? Polydentate ligand, right or not? Let us see which are the polydentate ligands. Let us see first one, option ammonia, monodentate ligand, it cannot. EDTA, yes, ethylene, diamine, tetraestic acid, it's a hexadentate ligand, it can definitely lead to chelation. What's option third given to you, children, here? Option third, acetate ion, CH3, C double bond O. No, it's a monodentate ligand. It can donate only from one of the oxygens, water, monodentate ligand. So, correct option will be option 2 only for this. Next question. Okay. Question number 147. One analytical question will take. A 6-coordinate complex of formula CrCl3 X times water has green color. Good. A 0.1 molar solution of the complex when treated with excess of AgNO3 gave 28.7 grams of white precipitate. So with AgNO3 it will give you AgCl, but we don't know how many chlorines are free. The formula of the complex would be, good question. So question number 147. Question number 147. Understand it well. So we have a complex CrCl3 X times water. When you are treating this with silver nitrate AgNO3, but how many moles of it are treated? Treating with silver nitrate, you are treating it, you are getting 28.7 grams of white precipitate. That technically will be AgCl. But we do not know how many chlorines have come out of it. You are getting this much of mass. We will convert this into number of moles, which is mass divided by molar mass. So it is 28.7 divided by molar mass of silver chloride is 133.7 most probably. So when you divide the two children, it comes almost 143 into 2 how much? 2 3s, 6, 2 4 8, 2 1 2. Almost double. It will come 0.2 moles. So we have got 0.2 moles of what? AgCl. So from here you got actually 0.2 moles of AgCl. But what is the molar concentration of this given in the question? Tell me the question given here, children. 0.1 molar solution of complex. So 0.1 molar solution, 0.1 molar of complex has given you what? 0.2 moles of AgCl. That means the number of moles of chlorine replaceable are how many? 2. How? So 0.1 molar complex giving you 0.2 mole. That 0.1 molar complex means what? 0.1 mole of complex is giving you 0.2 moles of AgCl. Tell me 1 mole will give you how much? 1 mole of complex will give you how much? 0.2 divided by 0.1. That is how much? 2 moles of AgCl. To get 2 moles of AgCl, how many moles of chlorine should be out of the coordination pair? 2. So what will be the formula of the complex? It will be Cr. Then water, it is octahedral complex, right? Since it is 6 coordinate system, 2 chlorines are outside the coordination sphere. That means there should be 5 water molecules. So it should be H2O 5 times. 1 chlorine will be inside and 2 chlorine is outside dot water molecule. This will be the answer of the question. Cr H2O5Cl, bracket closes, complex closes, Cl2. When you treat this one with AgNO3, definitely you will get 2 moles of AgCl. So correct option, children, will be which option? Only how many chlorines outside? 2. So correct option will be option 2 for this 147th question. Hope you are getting it out clearly. Next question. Question number 155. Rest questions are very easy. 155. Arrange the following complexes in decreasing order of their absorbed wavelength. Decreasing order of their absorbed wavelengths means what? According to the ligand strength, we have to arrange. We have chlorine, water, ammonia, CN. What's it? We have water, we have ammonia, we have chlorine, and we have CN. Now children tell me, CN is the strongest ligand. So, order of strength of ligands, what is it? CN more than NH3, more than water, more than Cl. So what will be the order of wavelengths absorbed? This is weak, it will absorb in most wavelength. This will absorb in least wavelength. So order will be wavelength absorbed in chlorine will be more than wavelength absorbed in water, more than wavelength absorbed in ammonia, more than wavelength absorbed in CN. This will be the order. Cl, water, ammonia, CN. Have a look on options. 1, 2, 3, 4. First option is the correct option because they have mentioned Cl complex has 1, H2O complex has 2, ammonia has 3, CN has 4. So correct option will be first option. Next question. 158. How many EDTA molecules are required to make an octahedral complex with calcium? Octahedral complex means how many ligands should be surrounding the central atom? 6. If 6 ligands have to surround the central metal atom, then the ligandic position should be from 6 places. EDTA we already know. What do we know? EDTA is hexadentate. What is it? Hexadentate. It can displace from how many positions? 6 positions. So only one molecule is required to make an octahedral complex. So correct option will be 1. That's option 2. Next question. Question number all questions are easy, children. You can have a look on this. Have a look on question number 178. 178 question. What's it asking us? The stepwise stability constant of a complex are given below. Good. The stepwise stability constants of a complex are given below. What is its overall stability constant? Ml, K1, then Ml combines with L gives Ml2, K2, K3, K4. Very simple reaction. So overall reaction is what? M plus 4L gives you Ml4. We know the individual reactions are there and the total reaction is there. For this we can write stability constant beta equals to Ml4 divided by M and L raised by the power 4. Now already we know what's the first step? M plus L gives us what? Ml. M plus L gives Ml. So it is K1. Then you have Ml plus L gives you Ml2. Then Ml2 plus L gives you Ml3. Good. Ml3 plus L gives you Ml4. So it is K2, it is K3, it is K4. The overall stability constant beta will be K1 into K2 into K3 into K4. Already discussed the terms very well. What is K1 given? Tell me the K1 value given. 10 to the power 4. K2 3. K3 10 to the power 3. K4 2. So 4 3 3 3. Sorry 4 3 3 2. 4 plus 3 7 plus 3 10 plus 2 12. Correct option will be 1 in 10 to the power 12 respectively. So overall stability constant will be the multiple of all individual steps. If you want to do that also have a look. Ml, right? Next one will be Ml plus L. This is product in first case, this is reactant in the next case. This will cancel, this will cancel, this will cancel. What remains there? M, 1, 2, 3, 4 plus 4L gives you Ml4 because all these are cancelling. Oh, yes or no? So you will get M plus 4L gives you Ml4. So for that it is beta 4. So K1 into K2 into K3 into K4. So 10 to the power, what's the value? 4. 3, 2, 1. So total will be 12 respectively. So this is the discussion of the paper. Hope you have understood the statements well and clearly. Clear or not? Right. So in our next discussion, we'll see what further to be done. Thank you. Have a good day.